Hi, I'm Deborah Byrd, and I'm here with our friend, Dr. C. Alex Young, who is a heliophysicist or sun scientist and the co-author of EarthSky's Daily Sun News Update. Hi, Alex.
Hi, good to see you.
Good to see you. So we are here to discuss a tricky subject today, the sun and our health. So Alex and I have both been looking around for scientific studies related to this topic, and it's 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 not straightforward. So we will say that it's not a straightforward subject.
Mhm, mhm.
And we're going to show you some of the studies that we found. But first, Alex, let's set the stage here. Like, where are we in terms of the sun and its activity?
Mhm. So right now we are in a phase called solar maximum. We are very near the peak of solar maximum. So solar maximum is when the sun's activity as is at its highest. The sun has a solar cycle that goes from low activity, high, back down to low over roughly 11 years. And you can see in the image you put up, there are three solar cycles here, 22, 23, 24. We are currently in solar cycle 25. Um, but you see in each one of these, there's a peak, and there's also sort of a period around that peak, which is roughly a couple, a year or two. And so that's where we are right now. Solar activity is much higher than other times, and we certainly have seen that looking at the data over the past many months.
Okay. And so when solar activity is high, we hear this from people: headaches,
Hmm. Hmm.
fatigue, mood swings, sleep disturbances.
Yeah,
Any
and it's
comment?
well, it's a really interesting question. The simple answer, even though it's a very not as simple problem, is we don't know. We don't know the answer yet. Um, and if you were to put that in the context of a study, a scientific study, you would say that it's inconclusive. We don't have an answer. Um, so it is possible that solar activity could impact our health. Now, from a purely scientific point of view in physics, the first reaction would be, well, probably not, because we are very well protected here on Earth, which is one of the reasons why life exists on the Earth in the first place. We have a very thick atmosphere of primarily oxygen and nitrogen, which is great for stopping very high energy electromagnetic radiation, certain types of ultraviolet, X rays, gamma rays, things that are very unhealthy for us. It also will helps to stop energetic particles, things that we think of often when we think of radiation from like a nuclear power plant or something like that. Um, and we also have a relatively strong magnetic field that surrounds the Earth, and protects us from a lot of the activity and the constant flow of what we call the solar wind coming off the sun. And we know that's important because we can see the effects on planets like Mars that don't have this magnetic field and don't have this thick atmosphere. And so we do have a pretty good understanding of that. So, you know, to first order, as we would say in science, um, there doesn't seem like there would be an effect. However, there are things that are happening, such as these huge eruptions called coronal mass ejections, which can jiggle our magnetic field of the Earth, and that can cause power outages. It can interfere with communication. Also, these huge blasts of light called solar flares heat up the upper atmosphere. Where the sun is pointed directly at the atmosphere, it heats it up. And when it does that, it causes radio blackouts that are temporary, but they disrupt radio communications. They can disrupt GPS. So we do know that these phenomena from the sun impact our technology. So the next question then is, how does that translate to you and I? Um, Something you and I were talking about earlier. There are magnetic fields all around us. We can't see them. And in general, we can't feel them. However, there are many animals that directly depend on magnetic fields, the magnetic field of the Earth, for example, to navigate. So their bodies are very sensitive to magnetic fields. So does that mean that human bodies are sensitive? Maybe. Um, and so it's not out of the question. So it's a really challenging problem, but we have magnetic fields that come from microwaves, magnetic fields that come from fridge magnets, magnetic fields come from the cell phones that we hold near our ears. Um,
Not
Magnetic
me.
fields. Magnetic. Actually, I will say these days I use headphones for the most
Yeah, me
part
too.
or earbuds. Um, Magnetic fields come from power lines, especially those big high tension power lines. And in fact, there are studies of cancer rates, near power lines and things like, cancer rates related to cell phones. So, if those in fact are real, and right now, again, they're still, some of them are inconclusive. Some of those studies, those medical studies, have said there is no impact. But this is one of the challenges of science is science is not based on a single paper. Science is not based on a single study. Um, and you can never look at a single paper and make any sort of definitive answer to a situation. Science requires study after study. The studies have to support each other. They have to build on each other. And so that's one of the key things that's really important to think about this is that it's not a single paper. And let
Right.
me
And
add one. Go
oh,
ahead. You go ahead.
yeah. And so what I was going to say, well, I was going to say two things. It's really hard to prove a negative. It's really hard to
Yes.
prove there is no effect because
Right.
it could be that we just haven't found that effect yet. So that's
Right.
true in any endeavor. It's hard to prove the negative. But the
Hmm.
other thing is that I mean, I think if we had been talking about this 10 years ago, you and I both would have sat here and said, no, Earth's atmosphere protects us. I mean, this has been the perceived wisdom for
Hmm.
forever. Like, let me go back to that image that we just showed of the Earth and Sun in space, and on the left
Hmm.
there's the Sun, on the right there's a little bitty ball of the Earth. This is not to scale, obviously, but it's showing Earth as being surrounded by this big magnetic field, and so there is this mechanism for protecting our bodies, and we felt for many years that that was the end of the story. But now,
Hmm.
here's a study from 2018, long-term study of heart rate variability responses to changes in the solar and geomagnetic environment. So this is one of the first papers, and this is in Scientific Reports, which is associated with the very prestigious journal Nature. So this is not
Hmm.
just some random study in some random journal. This is, affiliated with Nature. And so, this is a real study about a possible link between,
Right.
what's going on in the geomagnetic environment and what's going on in the sun with heart rate variability responses.
Hmm.
So stuff that's going on in our hearts. And of course, this is not the only study because then a couple years later, this study came out, geomagnetic disturbances driven by solar activity enhanced total and cardiovascular mortality risk in 263 US cities. So that's pretty clear what they're saying there. They're saying that
Hmm.
there is a link and
Right.
that it's enhancing the mortality risk. But as you said, this is just one study. I do want to say
Right.
also that this study led to some of the more popular media, like New Scientist,
Hmm.
picking this up. And this story is from 2022. Solar storms may cause up to 5,500 heart related deaths in a given year. In an approximate 11-year cycle, the sun blasts out charged particles and magnetized plasma that can distort Earth's magnetic field, which may disrupt our body clock and ultimately affect the heart. And I mean, that's
Hmm.
what, when we showed uh, that list of effects that people report,
Hmm.
that's what they're reporting. I mean, they're reporting sleep disturbances and mood
Hmm.
swings and headaches and just the kind of thing that this little cut line here is talking about. So,
Yeah.
circadian rhythm type effects that we
Right.
know affect our mood and affect our headache and that sort of thing. So, yeah, I mean, I guess that if I were going to have to draw a conclusion right now, the only conclusion I could draw would be these studies are in their infancy,
Yes.
and there need
Yes.
to be thousands more studies that
Right.
show these things before we can really understand what's going on
Yeah.
here.
And it's a difficult problem also because solar activity is not constant. So that's one
Right,
aspect. But it also means that if you want to do a study during solar activity when it's at its peak, it's difficult to do a long-term study because you then have to account for the fact that solar activity is changing. Um,
right.
this is one of the things that I honestly, I am very impressed by people in the medical field who do research because the amount of to do the research correctly, and I have a small understanding from the science process point of view. It requires things like double-blind studies. It requires having situations where you have a group that isn't exposed to something and a group that is exposed to something, but you don't know who is and who isn't. But how do you do that when it's all around us? This is an incredibly challenging kind of study to do. Um, Now, one of the things I wanted to point out, that's a couple of things that are important for the audience in terms of science, because we see a lot of really interesting science on YouTube. But the thing to remember is, um, if you really want to understand what a study is saying, you ultimately have to go back to the study. So when I say that, I don't mean that you can't, read a magazine like Scientific American or New Scientist and you know and not pay attention to it. But you have to be careful that to really understand, you ultimately have to go back to the study because sometimes science writers get it wrong.
Absolutely.
Sometimes, um, and
We're looking
it's
for the
because it's
headline.
yeah, it's very difficult.
Yeah.
And I've certainly seen that in some, space weather articles at times that are sort of frustrating for scientists like myself. The other aspect to think about is while all of our experiences are valid, I mean, we experience what we experience, we have to remember that that's not science. Science cannot depend on anecdotes. Now,
Right.
anecdotes, when you say I experienced something, the benefit for that is that allows the scientists to say, oh, well, why is that? Let me think about a possible reason, which then is a hypothesis, and then you do a study to test that hypothesis. Um, so it is difficult because there are lots of things in our environment that could be impacting us, and it's also why some studies, and many of the ones I've seen, do show correlation. They do show that something related to the body changes with solar activity, but they haven't gone to the next step of understanding, is it causing it? Do we know, for example, that it's causing it? And that's one of the aspects of science that's really difficult. It's hard, and there is no doubt about it. These are hard problems to solve, but they're very interesting. And
Yes. And I mean, some of these effects that people report experiencing, I don't know any way that they could be anything but anecdotal. Because if you say, I'm having mood swings, for example. Like,
Mhm.
how do you
Mhm.
measure that? Like, how could you measure that in a lab?
Right.
Or even headache. It's kind of like,
Yeah.
do you have a headache? Oh, let's see. Do I? Yeah, I do have a little bit of a headache. I mean, it's like, like
Yeah.
it's really hard to measure how much of a headache you have.
Well, I know I have family members who have migraines, who've had migraines their entire life, and those migraines they have noticed anecdotally, but they have noticed, and it's not just my relatives, that they tend to happen when there's a low pressure system and a storm comes through. Like if
Right.
there's a big storm, meaning there's going to be low pressure, they tend to remember having much stronger migraines. You
Well, I
know,
mean, I have a plant in my yard, a sage that
hmm
blooms with these beautiful purple blooms when a low pressure system is coming
yeah,
through. So it's
yeah,
like something is going on there.
something's happening. Yeah,
Like I don't
yeah.
don't know what the mechanism is, but there's something going on there. So okay, so the bottom line here is basically that this is a very interesting, the whole subject uh, of health and solar activity is very interesting. It's
hmm
the studies of it are in their infancy. There aren't very many
hmm
studies. There need to be thousands more studies
hmm
before we can say something conclusively about it. But there do seem to be in some of these early studies a correlation between solar activity and geomagnetic activity and possible body clock issues
hmm
leading to heart issues. So that's
Right.
sort of what has emerged at this point, and maybe those body clock issues are leading to some of these other things that people
Yeah.
are reporting too. So, you and I'll get back together in a year or two, and we'll see where the
Yeah. I
science is
mean,
on this. It'll be interesting.
it's yeah, it's definitely something that I'll continue to look at. And the other interesting thing about it is we do know that solar activity has an impact on human health for some people definitively, and that is astronauts. So we do know from the Apollo as well as from more recent astronauts that solar radiation, in particular energetic particles, not so much the light, but the particles do impact possibly cardiovascular. Cancer rates for certain classes of astronauts are higher, and they have impacted vision because these particles are traveling through the astronauts' eyes, and there incidences of more cataracts and other issues. So we do know that the part of the answer is yes, it does impact human health. Now, does it impact human health on the Earth? That's the interesting one.
Right,
That's the one that's still a challenge. Yeah.
right. There was the wonderful scene in the TV series For All Mankind, which if you haven't seen that, I want everybody to watch it because it's really good. And there's the wonderful scene in it where the astronaut is in a lava tube on the surface of the moon being protected from the solar radiation storm that's going on. But then her colleague, her fellow astronaut, has collapsed out on the lunar surface and she has to go out there and get him. And then it shows her in later life, she's got all kinds of vision problems and she's walking with a cane. And,
hmm
so it's depicting that. It's depicting that very thing that you're talking about,
Yeah,
that
and
there are these
that's very
effects.
real. Yeah, it's very real, and it's something that's really
Right.
important for us to study and understand because someday we want to, well, we're going to be going back to the moon. Someday we want to maybe even be going to Mars, and that's a whole nother ball game than going to the
Not much
moon.
atmosphere, no magnetic
Not much
field.
atmosphere. Plus, on your trip to Mars, you have a mini month trip, and you are very exposed on that trip.
Yeah. You'd have to have the shielded room in the spaceship.
Yeah, yeah. So it's definitely going to be a big challenge.
Hey, I've watched enough sci-fi, but
Me
I've got
too.
the answers.
Me too. Yeah.
Yeah. Hey, we're gonna have to get out of here, but I would like to just share one more thing. Hope I'm sharing the right thing here. Oh yeah, this looks right. Um, let's see, is that right? Yes. So This is the sun in the past 24 hours. So just there's some stuff coming off the edge there. That's the incoming side of the sun. So we may see that activity coming around to our side in the next day or so. But is this is this a
This still
SOHO
goes.
image?
That's a
Oh, it's
goes.
goes. Okay,
Goes, right.
but the word on the street is that SDO is back
SDO
in
is back.
action.
Yes, yes. We don't have the full data. Right now we only have 15, data every 15 minutes. Normally we would get data every roughly 36 seconds, so we don't have the high resolution, time resolution data, but boy, are we excited to have SDO back. We've
I know
missed, we've missed
I've
her.
really missed it too. I've
Yeah,
missed the images because they're so
yeah.
awesome. Yeah. Okay. So we'll talk more about that next week. Alex, thank you so much for joining us today. That is our show. And I added the references to the scientific papers that we talked about, plus a couple of more papers that we ran into this morning in the description notes on this video. So my thanks to you, Dr. Alex Young, a heliophysicist and the co-author of EarthSky's Daily Sunpost. Thank you for joining us today, and we invite you to come and visit Alex over there at earthsky.org. One Earth, one sky, EarthSky.